So hey, my name is Ben Vinegar, and I'm giving this talk. I don't know, kind of muse around about JavaScript errors a little bit. They're actually really hard to wrangle, and so we're gonna kind of talk about kind of the challenges of getting an error that's being reported from a production JavaScript application into some sort of logging system so that you can do something actionable with it, like fix something. So this is the button that clicks. Oh, cool. So I work at a company called Sentry. We build like an open source tool that basically is two parts. It's sort of like this client libraries that exist for many different platforms, be they Unreal Engine or Go or the .NET platform, browser JavaScript, etc. They basically, all these libraries are sort of like living in production applications. They live in your source code, and they listen for uncaught exceptions or anything you want to log manually, send those up to our server where we group just similar errors together, give you emails, and sort of like give you a dashboard where you can understand the state of your application. I'll show a screenshot in a second. Obviously, I'm just going to be really focused on JavaScript for this. I think that it's reasonable to talk. I feel like I'm qualified a little bit to talk about JavaScript errors. Sentry is really popular among JavaScript users. So this is sort of like package downloads of our JavaScript client library relative to sort of like other competing products in the space. And it's a pretty stark difference. Those two lines are Sentry, the blue and the orange one. We actually just renamed the package, and so you can kind of see that the orange one is kind of taking over. So we're kind of competing with ourselves there. And this doesn't include sort of like CDN downloads and all the like. What does this experience look like? It's pretty easy if you're ever interested in kind of like getting started with it. You import a library like many other things. You initialize it with effectively an API key and a URL. And then you throw an error, and that'll be collected. The reason why that key is a URL is because Sentry is an open source system. That is the URL of like Sentry.io, which is our software as a service offering of the open source system. But you can run it yourself on Azure, GCP, whatever. And you can send that into your own internal like Sentry server that you can stand up yourself. If you're curious what it looks like, if you've captured an error, you get a view that looks something like this. I don't know why I keep looking over here because I have a screen up here. We kind of give you a stack trace, what is the browser breakdown, how many users are impacted, when did we first see this, what version of your software did this occur, what commit maybe might have caused this. So the whole purpose is really just to give you like a lot of insight into things that are breaking in production in your JavaScript applications, Unreal Engine games, .NET back, Ruby, etc. One thing I'm going to come to is like how Sentry differs quite a bit from sort of like logging service. Like there's obviously many logging tools that are familiar to people, is that Sentry sort of deals strictly with like error metadata. And so we do grouping by default, as opposed to like if you're using like a Splunk or Elastic and you have to kind of like create regexes to sort of define how you group similar errors together. It just works that way by default. Okay, so in this talk, I'm gonna go just really briefly over kind of like what are the fundamentals of how even something like breaks on a web page and winds up into a system like Sentry or elsewhere. And then I'm going to talk about three distinct challenges that I think that we have time to go over. There's like a lot, but this is enough for us to just kind of go over today. If you've never used them before, how do you get errors into, like, how do you even report on an error that occurs in production? There's two kind of like global error handlers that achieve this. The one that is probably the most important is window.onerror. It has a signature that looks like this. You basically just sort of assign it to window, and you give it this function that takes a message, a URL, line, column, and error. Each of those are sort of like descriptive of what the error is. That last item, the error object, contains like a stack trace as a property. We'll come back to this in a moment. There is another sort of like a newer kind of global exception handler that's out there, which is on unhandled rejection. Hopefully I wrote that correctly. And this is basically listening for any kind of uncaught promise rejection coming from like a fetch or any kind of, promise type stuff. It's only supported natively in Chrome, but I think libraries like Bluebird, promise libraries kind of like support it. So there's other ways of getting to it. I'm really focused on error in this talk. So what does this look like? Well, imagine you have something like the following, where you have a function, and I'm just gonna console log those like arguments, and then right below it, I declare a function called foo. It calls bar. Yeah, I'm still doing the foo and bar thing. and then foo throws an exception. Then, output to the console, you're going to see something like this. Effectively, you have in order the message, uncaught reference to error, bars not defined. That's the error message. Then you have the URL where it was found, line number 6, column number 3, and then below that is sort of like, that's the error object. Error object has like a toString method that sort of like lays it out in this nice way. Yeah, that's what I'm trying to highlight there. So like this error object honestly is the most important part, and it's what gives you the stack trace, and the stack trace is the most valuable thing. However, like everything in JavaScript world, it comes with some limitations. One that people hit really early is when you want to use onerror, but you're also kind of like using maybe like a JavaScript loaded from a CDN or some different origin, in which case this code looks identical, but imagine that this slide's wrong. Imagine that code, imagine the code is in example.js, okay? So function foo, all that stuff is in this script file. If I did that, then the onerror handler has decided that you don't get to see that. And why does it do that? It does that because of the same origin policy. I think a lot of people are familiar with this policy. Usually when it comes with iframes or like my JavaScript can't reach into another tab or something like that. Same origin policy prevents you from doing that. It also affects this onerror handler, and that's because, at least my understanding is effectively trying to avoid a situation where an error that's thrown from a script from a domain that you don't control might reveal some private information about the user or something that you shouldn't see. So there's a solution to this, which is called cores. There's 2 steps. Cores is basically a way for you to kind of like tell the browser, hey, like don't worry about it. This is safe. Don't worry about any like privacy information. One step is you go into your sort of like CDN script and you say, hey, this is an anonymous file. And the browser will actually load this file and not send any cookies, right? So it's trying to say like, there's no session data kind of attached to this. And then you have to go into the file that you're serving out, and you have to return a header that says access control at origin. And you kind of just tell the browser like, hey, like any origin can download this file. And once you've done those steps, then this onerror thing will kind of work as it did before. It's really infuriating because if you don't do this, it just says script error, and that literally just doesn't tell you anything. It doesn't tell you line, column. So I won't even tell you the thing that you've kind of gotten wrong. So it's really important that you do this. There is a workaround that we kind of abuse a lot in Sentry, which is, imagine you have this exact same example. I'm bad at slides. That's like that should be like the CDN file again. And I try to call this function foo that is declared in that example file. If I try and catch it, I'll actually get the full stack trace, okay? But the moment that bubbles up, back up to that global error handler, I've lost it again. It goes back to this kind of like generic script error problem. So what we do is effectively, we've decided that in order to help people be more successful, because it's kind of hard to go in and like, hey, I'm gonna go and reconfigure Nginx or all my CDNs to return these headers. I'm gonna go and update these script files all over the place. We really just want you to install this library and it just works out of the box. So we instrument a lot of sort of like browser built-ins to do that try-catch for you so that we get ahead of this cores error. So much so that when you even kind of start your application, we're like, hey, actually, this is the one thing we can't instrument. So can you wrap this in this like wrap function? And that's basically just like a try-catch. Of course, JavaScript is like really, it's asynchronous. There's a lot of places where, sure, I can write some code and I can try catch that code, but the moment I, React decides to asynchronously render something, or I decide to like set timeout, or there's a click handler, I kind of am starting from a whole new kind of like stack. So part of our client libraries actually instrument all of those built-ins and say like, you fired up like a click handler, we're gonna try catch that. Or you're doing like a fetch request and so on. There's other benefits that we get out of this, but right now, like this is just one of those things that you do to just try to like make stack traces work when you're collecting errors. So that's a little bit on just sort of like making onerror work. Non-error exceptions. So what is a non-error exception? So imagine I'm writing Python, and I decided to do something like the following, which is I'm going to raise, that's the equivalent of throw in Python. I'm going to raise a string. The Python interpreter will say, whoa, whoa, whoa. Exceptions must be these classes are derived from base exception, not a string. Get out of here. And the Python interpreter is very nice. It will, if you have like a global exception handler, it'll preserve that stack trace. It'll tell you where you kind of got it wrong, and you'll kind of understand what's happening. However, if you do the following in JavaScript, which is sort of equivalent, I have this like onerror handler. This is what happens. I do get the message, and I do get the URL, and I get the line in the column. But that last argument is the error object. And the error object is the thing that holds the stack trace. And it has been completely replaced with the string lol. There's no stack trace, there's no anything. So if you do this, you again bring us back to this like really tricky scenario where imagine you're reporting this as being logged somewhere and you're trying to go back. You don't even know. You know the exact line in which this is occurring, but you don't know how you got there. Only file name, line and column, there's no stack trace. Now you might be thinking, well, how often am I like throwing a string? Probably not doing that very much, but you're probably doing other things that you might not realize, like maybe you're rejecting a promise with a string, or you're rejecting a promise with a number or a false or something. And this has the exact same effect. So if I brought it all the way back, like there is that global like promise rejection handler. If you're ever sort of like resolving a promise and saying something that is not an error, you're actually creating the same scenario all over again. So this happens like a ton. So if you ever used a service like Sentry and you're kind of wondering, I got all these promises, but where's the stack trace? Where is this stuff happening? It's because of problems like this. These examples are actually from ESLint, because you can actually set up an ESLint rule that enforces you to, at least as much as it can figure out, to say like whenever you're trying to like mess around with promises, you should probably pass an error. And if you do that, again, if you're working with a service like ours, you'll get a lot more kind of like a lot more value out of those kind of error reports. However, try catch comes back again. Try catch is very useful. So imagine we have the same example, and I'm bringing back this like onerror handler, and I try to throw this string. And again, like this, it can be a string. It could just be like a an object or anything. If I do this, effectively what I'm basically doing is creating an error that generates a stack trace up until that point, and then I throw the thing I was trying to raise into that error, and I re-raise that, and it gets caught by the onerror handler. And so why would I do this? Well, you'll notice that sort of fifth argument is actually like, now it's no longer just the word string, it's actually an error, and there is one line of a stack trace. So this is a stack trace that points to the point at which in which it was sort of thrown, right? And that's more helpful, because at least you can actually kind of like, sure, this is just like a stack trace that's one line, but imagine it was like 10 frames deep. You can actually retrace your step and figure out how you actually threw this like bad thing. The only downside of which is that it's going to point to this sort of like instrumentation. So in this library that we use with Sentry, we do this. We do this for you, again, because a lot of people do this all over the time. I would say like 100% of every user has some problem like this. However, our own library then shows up in the sort of stack trace, and we show inline source code. And so people then come back to us and say, aha, you broke my website. And so that's why we have this comment that's in the source code that is just like, hey, if you got here, there's a reason. Just think about it. And that's actually been very helpful. People listen to this. So non-error exceptions, they're caused whenever you throw any non-error, more accurately, an object that does not have this like stack property, which has a stack trace. And it makes determining the root cause of all these problems really difficult. Promises is like, I would say, one of the most common source of them. And by doing this sort of like instrumentation, it's kind of wacky, but you get this added detail that's really nice. One last thing, there's a dozen things, but we're gonna go with this. I talk about just sort of the environment challenges of, browser JavaScript that make error reporting hard. So if I'm writing a Python application, and it's like a non-trivial application, I need to scale it. So I've got, I'm gonna put my application on 4 instances somewhere in the cloud, and they're all running hopefully the same version of Python, and they're all running Docker. If I have like a crash, like imagine I'm pushing code and that code is broken, I called foo somewhere and it blew up. The stack trace that comes back from server A, server B, server C, server D, they're all gonna look the same, and it's not, I can group all those together, and this doesn't require, really make anything more problematic. Even if you do have like something that's a little out of date, at least you control this environment. You can push updates as you wish, right? So if I'm running like an old version of my software, an old version of Python, eventually I'll update it. Imagine instead that you were building applications, you were scaling out your server application like this, which is, you know what, I'm writing Python here, but I'm feeling bold. I'm going to run Jython. I'm going to run PyPy. I'm going to run 3.7. I'm going to run 2.7. And if you're not aware, like, Python 3 is like wildly incompatible with Python 2. Also, I'm going to run it on Windows because I'm part of the chaos engineering team. Windows is a really good example because, that stat trace that's generated would, for example, like the slashes would be backwards as an example, right? This would be very challenging if you're trying to understand, like, if you had the same source code error, what would this look like? And that's the world, obviously, that we all live in today. That is really tough. And obviously, this affects more than errors. It affects our whole lives. That's why we come up with all these crazy things. So imagine you have Chrome with the Avast browser plugin. That can cause some trouble for me. And now I've got Chrome again, but except, this isn't actually Chrome. This is a web view on iOS. So it's actually running JavaScript core. It's not running V8. Or you've got IE, and by the way, this user is in Spain, so all of the error messages are localized in Spanish, and of course Firefox, etc. You can imagine how this makes things really tough. I'm going to highlight one of the most challenging examples. A lot of people, I think, even on our own team, aren't aware of. So this is a purposely contrived code snippet. I'm going to try and walk through it. So it is a class, which is just a function. And then in that class, I'm going to take the prototype and I'm going to like set this property called bar, which is a function definition that calls Baz, and Baz doesn't exist. Yeah, you got to get rid of this foobar Baz stuff. And then below that, I have an anonymous function assigned to a variable called foo. And these characteristics, these small differences are important. That creates an instance of the class and then calls that method. And below, I have an immediately invoked function expression that calls foo and kind of kicks the whole thing off. So in three of like the most major browsers, what does that look like? Shockingly, perhaps not shockingly, very different. The stack trace property is actually not, it's not specified. There's no spec. And so it's really up to anybody's interpretation about what it looks like. The error object, there's a spec for that, and that spec just says there's a stack property that is undefined. So what you get is kind of something like this, where everybody has a different definition or sort of like a different explanation of what things look like. Maybe not even just a different explanation. I think even just some interpreters actually understand what they're executing perhaps better than others, right? It's like maybe a choice. For example, like Firefox knows I am calling my class.prototype.bar on that first frame, whereas Safari just knows that it's bar. And Chrome has just thrown that out. Oh, Chrome knows that it's my class.bar, which could be confusing because that makes it seem like that's actually just a property strictly on my class, which is not true. And so forth. Hopefully you can see the examples. Safari also sort of identifies like a global execution context, etc. We normalize this as pretty much everybody who does this kind of stuff does. But even if you strip away all the things that are different, you are hit with this sort of like intractable problem, which is the browser, like the JavaScript engines actually disagree on what line of code is even executing for certain frames, right? So in this case, like this immediately invoked function expression seems to cause browsers a lot of different grief, right? Firefox thinks, it's actually at the beginning of that variable foo. Safari thinks it's at the sort of like end of this line, and Chrome thinks it's actually the beginning of the next line. Fundamentally, Sentry and other tools like it, when we group, we look at the stack trace and we try to say like, oh, these are the same error. But if the browsers fundamentally report different lines, it's really hard to figure that out, if not impossible. The good news is that this is an edge case. It's not what everything looks like, but it is problematic. So yeah, engine challenges, different line column numbers, different culprits, and perfect grouping is impossible. That's why we sort of play around with things like heuristic-based approaches for munging things together. Okay, what was the point of all this? I think the point was merely just to, one, just talk about how actually some of these things are really challenging. The difficulty when you go from like a really sort of, a server environment that you control to sort of like browser world, like the difficulty just goes up to 11. wanted to highlight how just setting up this error handler is sort of insufficient. Try catching the world actually offers a lot of value for cases that are not obvious. JavaScript engines produce different results. And also be careful what you throw, I guess, because I guess that's a good takeaway as well, because you may be dropping information that you didn't intend to. This is obviously just a meetup. I could drone on about this pretty much all night on some sort of crazy bender, but these are some of the other things that Sentry deals with that you may not be aware of, i.e. error translations. I touched on that. Edge today still generates error messages that are translated. So when you, like, undefined is not a function, undefined in function, I don't know, I'm not very good at French. That will actually be generated as a string. So we, for example, like, we have the translations and we'll do that sort of automatically for you. Minified source code, obviously if the stack trace is just sort of like function A, B, C, D, E, F, and you've lost all of that original context, it's gonna be really hard to understand what happened. It's also hard to understand what happened when those variables can change between builds, right, depending on how your code has changed. So Sentry and other tools like it take sort of source maps and like unminify your stack traces so you can make sense of them. We're also living in a world of minified error messages. Like React will actually say, you know, minified error number 34, go look somewhere else to figure out what that means. Browser extensions cause a lot of grief. Universal JavaScript, where, you know, I want to use this sort of like same JavaScript to sort of like log my errors, but I also want to run this in Node. I want to you know, do React server side. I want to do React Native. That also presents a whole bunch of challenges and those things that we deal with around that. So again, if you are interested in doing this, I do recommend checking out Sentry, or honestly, like any tool. Like if you're not using a product like this, I really recommend that you do. One of the benefits of Sentry is that it is open source. You can clone it, you can run it. We provide a Docker container. That's something you can check out. There's a lot of stars. I used to be the maintainer of like our JavaScript library. That's why I can drone on like this. But to the people that work on this today that do really great work and are responsible also for Node and React Native and kind of anything even remotely touching JavaScript is Jana Greiser and Camille Olgarek. Those are their Twitter usernames. So that's kind of all I got. If you're interested in sort of like want to play around with window on error, you want to understand a little bit more about script error, I've written some blog posts in the past that kind of like go into like way deeper than what I've touched on here. My name's Ben, and if you want to talk afterwards, I'll be hanging around.